Hello, I welcome you all in this presentation. This presentation is related with the subject fundamentals of the manufacturing processes, and today I will be starting the new topic, that is the casting. So, in this presentation, first of all I will talk about what the casting process is, what for it is used, what are the material properties that matters for successful casting, as well as what are the important steps of the casting process. So, as I have said, the topic is casting. So, the casting is used for making various products for a wide range of the applications, like in automotive industry, in form of like piston, connecting rod, engine block, etc., and like in the cement industry for making girth gear. So, these components may be from very simple shapes to very complex shapes. So, the process is very much capable to make very simple to the complex shapes of very thin sections in to very heavy sections, like having the section in even meters. For small size castings of few grams to number of the tons, like maximum up to 200 tons castings also have been made, and these castings are normally use the metals of the two categories. We can put them in two categories. One is like ferrous metals and non-ferrous metals. Since the ferrous metals are of the higher melting temperature as compared to the non-ferrous metals, so it is somewhat easier to cast the non-ferrous metals, but there are certain ferrous metals also which are extensively used as a casting metals. So, among the ferrous metals we have the cast irons. This is named so because it is very easy to cast, comparatively it is easier to melt, and then because of the good fluidity it can take the complex shapes also easily. So, the castability of the cast iron is good, that is why it is called so. Then it is also used for making the products of the cast steel, and cast stainless steels are also used, stainless steels, like martensitic cast stainless steel is used for making the hydro turbine blades, where good hardness is required for erosion and cavitation resistance. Cast irons are extensively used because they are cheaper, as well as they are very easy to cast. So, most of the like municipal the components products used by the municipalities, like manhole or the benches, etc., machine beds, are made of the cast iron. Among the non-ferrous metals, what we have, like non-ferrous metals, we have various categories, like magnesium, alloys, aluminum alloys, zinc alloys, and also lead and tin are also used as the common non-ferrous metals. Because of the low melting point temperature of these metals, these are easy to melt, so they can be given shape through the casting route. So, one of the these are the capabilities, like they can handle very small size to the large size castings from very simple shape to the very complex shape, and this is the fastest route for getting primary shape of the product which is desired. We need to just melt the metal and put into the mold of the desired shape, so that after the solidification we can get the product, but it suffers with certain limitations also, and these limitations primarily include like the tolerance which is achieved in the cast products is high, it is not very close. So, the dimensional variability is more, and the surface finish which is achieved through the casting route is also not very good. Most of the time it needs the machining. So, maybe very good surface finish of the order of the 2 micrometer, and like poor surface finish in sand mold cast components as high as 25 micrometer, when RA is the roughness parameter. So, this is one aspect, that the quality in terms of the dimensional control and the surface finish is somewhat poor, and then second aspect is that the process is very labor intensive. So, lot of manpower is needed for, especially for preparation of molds, handling and disposing of the used product as well as the raw material or the waste material which is produced as a result of this, for handling of the molten metal, handling of the raw material to be melted in, putting into the furnace, and then molten metal is to be handled and brought to the mold, and then it is poured into the mold, and after the solidification the component is taken out of the mold. So, all these things require a lot of manpower. So, it is the labor intensive, and however, the efforts are being made in order to reduce the extent of labor which which is being used currently, using the mechanization of the different steps of the casting process, so that the human component as well as the manual intervention related to the casting process can be reduced. Another is since the process involves the melting of the molten metal at high temperature, it becomes sensitive for reactions, interactions with the gases and impurities, followed by the solidification in which liquid to the solid state transformation takes place. So, depending upon the cooling conditions, the system becomes very prone for, castings are prone to have defects if the things are not controlled properly in terms of the design, mold or gating in the riser design. So, the prone to have the defects in the castings. So, these are the limitations related with the casting process as a whole. We know that these are the metal systems of the two broad categories, ferrous metals having the higher melting point temperature as compared to the non-ferrous metals having say low melting point temperature. So, basically melting point temperature determines the ease of the melting, and which in turn will be affecting the kind of the heating system or the furnace to be used to have the molten metal for the casting purpose. So, but this is one of the points related with the metals to be processed through the casting route. So, we need to consider in totality what are the factors that matter actually in casting or what are the properties of the metals which are important for the casting. So, metal, we will try to look into the metal properties which matters for the casting, includes like metal properties, there are two categories related to the metal properties which are important, and these are the physical properties and chemical properties. So, if we try to see what are the physical properties that are important, so the first is the melting point of the metal, and melting point of the metal must be considered for determining the kind of the furnace or the melting facility is to be used. So, selection of the furnace or the melting facility is to be used is determined by the melting point of the metal to be processed. For example, resistance heating furnaces can be used for melting the low melting point metals like the magnesium, zinc and aluminum, but like arc furnaces are needed on the other hand for melting the high temperature metals like steels and the cast irons, although cast irons being of the low melting point like say 1050 to 1150 degrees centigrade. So, this is the kind of temperature which can be achieved using the coal fired furnaces also. Then after the melting point we have a specific heat. It is this specific heat related with the metal determines the amount of heat it can carry in the molten state. So, that heat must be dissipated to complete the solidification. So, if the molten metal, if the specific heat related with the metal is high, then it will require to reject lot of heat to complete the solidification process, means solidification time for the high specific heat metals under given conditions will be more, which means it will take long time before the solidification, which in turn improves basically the fluidity, because the solidification time becomes high with the increase in the fluidity. So, basically the specific heat is the another property that determines the solidification time and which in turn affects the fluidity of the metal, means extent up to which it can flow before commencement of the solidification. Then we have thermal conductivity. Thermal conductivity. Thermal conductivity of the metal is important because it determines the rate at which heat will be transferred from the metal to the mold. So, high thermal conductivity metals will be cooling will be transferring the heat faster as compared to the low thermal conductivity metals. So, in this case when the thermal conductivity is high, then solidification time will be low, and if the solidification time is limited, then of course it will increase the productivity by reducing the casting cycle time, but on the other hand it will increase the tendency for the defects like misrun, means incomplete filling of the mold cavity, or it may lead to the shrinkage cavities, because the solidification will be completing much earlier. So, shrinkage cavity or shrinkage porosity related problems are encountered if the solidification time is limited. Then thermal expansion coefficient, thermal expansion coefficient. Thermal expansion coefficient alpha is important with regard to the two aspect, that is the expansion and contraction which will be occurring due to the heating and cooling. Expansion and contraction, expansion will be occurring in course of the heating and contraction during the cooling. So, especially in case of casting, contraction is more important because it determines number of aspects like the shrinkage in the two stages which will be occurring, or contraction which will be occurring in two stages. One like liquid to the solid transformation due to the in course of the solidification. So, it affects basically the riser design. What volume of the molten metal is needed to counter the shrinkage related with the liquid to solid state transformation, that will be affecting the design of riser, or that will affect the molten metal which should be there in the riser, so that it can compensate the shrinkage taking place due to the liquid to the solid state transformation. And another shrinkage which is important is the shrinkage occurring due after the solidification from the high temperature, just after the solidification to the room temperature. So, this kind of shrinkage which is occurring in the solid state after the completion of the solidification, cooling down from the melting point solidification temperature to the room temperature, lot of shrinkage takes place, and that leads to the reduction in dimensions of the casting, and therefore, it affects the design of the pattern, or the dimensions of the pattern which is used for making the mold. So, thermal expansion basically affects the shrinkage aspect, which in turn affects the pattern design as well as the riser design. Other aspects related with the shrinkage also includes the development of tensile residual stresses. Tensile residual stresses due to the shrinkage, especially in the cases where core say does not collapse in the core which has been placed inside the mold for making the internal cavity. If this core does not collapse, then it leads to the tensile residual stresses, or if the design of the casting is such that it resists the shrinkage which is taking place, then also tensile residual stresses will be taking place. And if these develop, the magnitude of the tensile residual stresses is too high, then it can lead to the two aspects. One is distortion in the casting in form of the wrapping, or it can also lead to the hot tearing. So, high tensile residual stresses will lead to the cracking in form of the hot tearing or the distortion. So, it is important to look into the thermal expansion coefficient related with the metal being processed, so that the design of the pattern, design of the riser, and design of the casting itself can be taken care of, or the mold material can be selected suitably, so that the tensile residual stresses being developed can be taken care of, or the casting of the desired size can be achieved, which is free from the defects due to the defects occurring due to the shrinkage of liquid to the solid state transformation. Another important physical property is the density. Density for a given volume of the molten metal, density determines the weight of the molten metal or weight of the casting. So, this weight of the casting is important in the two ways. One is that this weight of the molten metal must be supported by the mold. So, if the mold is not able to support this weight, then it may sag or it may settle down. So, change the shape and size of the casting. So, instead of having the shape as per before pouring the molten metal, it subsequently due to the weight, if due to the weight the mold walls are shifted, then there will be change in the dimensions and the shape of the casting. So, this is one aspect, that suitable mold strength is influenced by, or suitable mold strength, what should be the mold strength, that depends upon the density of the material, because for a given volume, if the density is low, then the metallostatic pressure being applied onto the walls due to the weight of the molten metal, that will be limited, and if the density of the metal is high for a given volume, then the heavy metallostatic forces will be acting onto the walls and they will have tendency to shift the position of these walls, which in turn will be leading to the change in shape as well as the dimensions of the mold. So, the mold strength, what strength of the mold should be there, that is influenced by the density of the metal for a given volume. Another important thing is the core, strength of the core material as well as the core sheet or the core print, which is need to be there. So, these two designs are also affected because the entire pressure of the molten metal is will be acting on the core, as well as the buoyancy force will also be acting on the core. So, buoyancy force is actually determined by the density of the metal being poured and the density of the core material. So, metal and density of the metal and density of the core metal. So, this the difference in these two multiplied by the volume of the core, that actually determines the force which will be acting onto the core. If this force is too high, then the mold will have the core will have tendency to get fractured or collapsed or break. So, the core design, core strength is influenced by the density of the metal which is being processed. So, considering these points, if you see the melting point, specific heat, thermal conductivity, thermal expansion coefficient and the density are the important physical properties which affect the different aspects related with the mold or the melting or casting. So, it is important to consider the physical properties of the metal. Among the chemical properties which are important for the casting includes affinity. We know that most of the metals become very active at high temperature. So, with the increase in temperature up to the molten state, if the metal is having high affinity to the gases like atmospheric gases, then they will have tendency either to form like oxides or nitrides, etc. And so, these will be there in that case present as inclusions if not removed or filtered or taken care of properly. So, greater is the affinity, greater will be the tendency for formation of the inclusions. Another important aspect is the solubility of the gases in liquid and solid state in a given metal. So, the metals for which difference in solid and liquid state solubility to the gases is high, means like say if you take any gas like hydrogen, in the liquid state if solubility is high and in the solid state solubility is very low. If this difference is very large, then it leads to the rejection of the gases or rejection of the hydrogen in this case to the atmosphere in course of the solidification. So, we know that during the solidification liquid to the solid state transformation takes place. Since if the solubility of the gases in the liquid state is high, in course of the solidification these gases will be released. So, these gases must get enough opportunity to escape from the molten metal during the casting, and if it does not happen, in that case these will be present in form of pores or blowholes. So, these are simply casting defects which must be taken care of. So, basically it is related with the solubility of the gases in the solid and liquid state. For example, aluminum has a lot of difference in the solid and liquid state solubility, and that is why it is found very prone to the hydrogen related porosities. So, another important aspect related to the chemical properties is the composition, of the casting metal or metal to be used for the casting purpose. So, there are two things, one, either it is alloy or it is pure. So, we need to consider both the cases separately. Alloys are also of the two types, having a solidification temperature range, or you can say one temperature of solidification. So, there are alloys of the two categories where we have a wider we have a solidification temperature range, or the solidification is occurring at one temperature. So, in this case, if we see the pure metals solidify at one temperature, and the alloy of the eutectic composition also solidify at one temperature. So, both of them fall in same category, where there is a drop in the liquid temperature. Say this is the liquid metal, and here the solidification starts with the nucleation and then growth. So, this is the temperature in which solidification will be progressing, and this here it starts and it ends, and then again cooling starts. So, this is the kind of the cooling curve which is obtained, temperature in y axis and time in the x axis. So, this kind of the trend is shown by the either pure metals or eutectic metal systems. On the other hand, there are certain metals with the solidification temperature range, means certain alloys with the solidification temperature range, they will be solidifying completely in different way, where initially the solidification there will drop in temperature from the liquid state, and then there is arrest in temperature, and then temperature will be decreasing slowly, and then here it ends. So, here start of the solidification, here solidification ends, and then again drop in temperature. So, this is the range of the temperature over which solidification will be occurring. So, here Ts and Te, we can say temperature start at which the solidification starts, and T is the temperature at which solidification ends. In the same way, this is the x axis is time, and the y axis is temperature. So, the temperature remains constant in course of the solidification in case of the pure, and the eutectic temperature, while the temperature continuously decreases in course of the in case of the alloys having a solidification temperature range. So, what we will see, the implication of this is what? If there is a mold of any shape, it is full of the say molten metal. So, since the entire molten metal will be solidifying at one temperature, say this is 1500. So, entire mass will be solidifying at one temperature, almost simultaneously entire mass will be solidifying. So, this is very good side, and this kind of systems are found less prone to the defects. So, pure metals and the eutectics are less sensitive to have the defects as compared to the alloys having a range of the solidification. Similarly, while in other case the things will be solidifying first near the walls and wall of the mold, and then it will be progressing towards the center gradually, and here at the end we are left with the molten metal to solidify at the center. So, solidification starts at the wall and then it progresses towards the center or towards the region last to solidify. In this case, most of the time we get the purer system at the walls, the region which solidifies first and then region which solidifies at the end. In that area the concentration of the alloying element high in concentration of alloying elements. So, this leads to the lot of segregation when the alloy solidify over a range of temperature, and this kind of segregation leads to the variability in mechanical properties and the tendency for the hot tearing or the hot cracking of the metals. Now, I will quickly go through the typical applications using the photographs related to the castings. Like application of the castings, a simple piston, comparatively simpler shape for which casting is used. This is of aluminum. This is the typical pump casing which can be made. This is complex, somewhat complex in terms of the geometry, and further complex geometry is of the engine block. And such a complex design and geometry components can be produced with the casting in one go, and this is a very large size girth gear which is also made by the casting, followed by the machining in order to have the desired geometrical dimensions. And then further this is the crank shaft which is made through the casting routes, and this is subsequently machined and then grinding is carried out in order to have the desired the tolerance as well as the surface finish. So, the other things like this is also further complex design of the guide vanes or the blades which can be easily made using the casting process. This is what I have already talked about. The metals, there are two categories, non-ferrous metals and the ferrous metals. The aluminum, magnesium, zinc alloy, lead, tin and the copper alloys in the ferrous category, the cast iron, steel and the stainless steel. Here we have the material properties and the casting relationship. Among the physical properties, it is the melting point which determines the kind of facility to be used and the casting process to be used for the casting purpose. Like the low melting point metals can be like for example zinc, lead and tin. The hot die casting process can be used, while for the high temperature metals like aluminum, copper and the cast irons, the cold die casting is used. The specific heat affects the fluidity, as I have already explained. Thermal conductivity affects the fluidity and the solidification time. It also affects the riser design and gating and risering design. Thermal expansion coefficient affects the development of the residual stresses, which in turn determines the distortion and the hot tearing tendency. So, this is what I have already mentioned here. So, this will also be affecting the kind of pattern design, mold geometry as well as the material to be used for the pattern making. Then the chemical properties in terms of the like affinity to the atmospheric gases determines the kind of impurities which can be formed in the molten metal. So, more is the impurity formation tendency, greater will be the filtration requirement. It affects the pouring design because the pouring basin is to be designed in such a way that impurities can be filtered out, and it also affects the gating system design. Then solubility of the gases in the liquid and solid state affects the pores and blowhole tendency formation because of the difference in solid and liquid state solubility. Then chemical composition affects the fluidity and the chemical heterogeneity. Pure and eutectic systems solidifying at one temperature offers the greater fluidity as compared to the alloys which solidify over a range of temperature, and the pure systems as well as eutectic systems will have better chemical homogeneity as compared to the alloys which will be solidifying over a range of temperature. So, this is what was the brief of the role of the metal properties in the development of the sound casting process. So, here now I will summarize. In today's presentation I have talked about the metal properties which affect the different aspects related with the casting process, as well as what are the advantages and limitation as a whole of the casting process, and what are the general applications for which casting process is used. Thank you for your attention.